continuing our exploration of the Pinacol rearrangement, which I want to remind you is the dehydration of a vicinal diol with a strong acid like sulfuric acid or hot and heat. And of course you get water. I didn't show it. And you're gonna, I can promise you, you will need a second copy of your vicinal diol. I think lately, if you look at more recent exams, I already have a couple copies for you, because you're gonna have to get rid of each OH for the separate products, okay? One of the products, one of the alcohol is going to lead to two products, and the other alcohol is going to lead to one. How's that? But first of all, we have to remember a reaction that makes an alkene into a vicinal diol. Yeah, that stuff doesn't go away. So what chemicals are going to be added to this to make this vicinal diol? We only did one reaction that made vicinal diol. Yes, OS, osmium with 4 O's. Half credit for that. And then either the tert-butyl OOH or OSO4 with NaHSO3. Makes vicinal diol. And in one of our mechanisms, we're going to protonate this alcohol. And the other one, we're going to do that alcohol. We're going to need another hot, or sorry, in this case, sulfuric acid. Protonate the bottom one here. Protonate the top one here. 2 separate oxoniums coming up. Two separate oxoniums. This one right here. And it's going to leave. This one will go to this oxonium. And top. I'm not liking this top one as much. I hope you are similarly disposed with your opinion, because that's a secondary cation. It's going to be a lot slower to make this cation than it is going to make for that cation. So we got purple stream versus blue stream. Blue stream. Whoa, sorry about that. No idea how that happened. Need the bottom of my screen. We got a cation down here. It's a nicer cation. And I'm thinking maybe, if I'm smart, I can go from the alcohol stage. If you can do the rearrangement mechanism first, then you can combine it. And please just look at this cation here and tell me which product comes from this cation. I think, okay, I think it's this one. Why do I think it has to be this one? After resonance, or sorry, after rearrangement, I think you wanted to say. There's resonance. And if we have our base ready, we can go to the product. OSO3H negative. Grab H, make pi after the rearrangement has happened. Good stuff. And I like this other blue one for the first product. Can you get me there? It's the same thing, isn't it? What has to move You can't just make a pi bond here. There's an H there that's not here. H moves. Guys, you got to show me that H. Sometimes you got to draw an H. Move it, and then do your acid-base thing. OSO3H negative, grab H. Sigma, oh, I want red for my arrow. Sigma becomes pi, rearrangement already happened. And then that's what happens if you move an H. Now, instead of moving the H, I can move this bond here. Go from there to there, in which case you'll have a cation up here that can resonate. That one I'm going to show because we're going to go to this one. It's the second product that comes from the same cation. You got to do a carbon copy. Don't even think we use that expression anymore. Carbon copy. Organic chemists can use that expression. I'm going to show the rearrangement this time and only the rearrangement. Notice that arrow went all the way. It's a legal rearrangement from an, oh, don't draw that bond. Got rid of that bond. Yeah. My product's wrong up there. I'm sorry. Can I fix my product? I apologize. This is the product. Please edit your product. So that's the product up there. This one, yeah, just kind of make it look like that first. Okay. And the methyl's here. And there's double bond to O here. There. Now it looks like what I just showed. I broke this bond, and it's now bonded over here. There. I did not break this bond or this bond or this bond. My apologies, I had the wrong product there. Please fix this product. And then this rearrangement gives this. I'll show the red bond is the new bond. It moved. It followed the same rules the H followed. Take an atom from the adjacent position and move it to the cation. Take an atom from the adjacent position, in this case this carbon, and move it to the cation. There it is, move to the cation. This is a good cation. I know it's primary, and you said, oh, he said we're not allowed to draw those anymore. This has nothing to do with primary. This thing can resonate with the lone pairs on the O, which is what you're going to do now. We'll go green here. Ooh, sorry, I didn't say that. OSO3H negative. Yeah. These are going to take practice, everybody. But you've got lots of examples on old tests.